In today's fast-changing world, business initiatives and action plans have a short expiration date. Supply chain risk management has become a board-level agenda topic. From CEO and CFO strategic and financial priorities to operational managers, businesses are looking to enable supply chain resiliency both in the short term, mid-term, and long term. Different types of disruption linked to uncertainty and unpredictable events require new capabilities that provide effective and efficient organizational responses. One of the keys to achieving this is having better visibility in supply chain orchestration across the entire business ecosystem. The Cosmo AI simulation platform provides a high-fidelity digital replica of the entire supply chain and end-to-end visibility into the planning process and the operational system. It offers the unique ability to replicate all activity and interactions throughout the production chain, regardless of the number and location of your manufacturing sites, suppliers, contractors, and subcontractors involved. Another way to visualize the information of the production chain is the supply chain operation flow map. Here you can explore the multimodal transport flows as well as the relationships between the various production resources and operations. The solution's main interface allows users to create scenarios, adjust the scenario parameters, launch simulations, and visualize the results on the main KPIs. On the Scenario View dashboard, you can also quickly visualize the state of your production resources and capacity. You can then design, customize, and modify what-if and how-to scenarios for any timescale, system, set of constraints, or available resources to gain an optimal, actionable plan calculated specifically for your chosen KPIs. Within a few clicks, you can create two types of scenarios: a scenario based on the digital twin that we will call a master scenario, and a scenario that will be created from an existing scenario data, the child scenario. The Scenario Parameters interface provides several advanced possibilities related to the model and the scenario dataset configuration. The Mass Action Lever feature allows you to quickly retrieve the data from the Microsoft Azure Digital Twin loaded in the solution through the Generate Download Link button. You can also select and upload all or a selection of a locally stored dataset to create alternative scenarios. Another configuration option is to directly adjust the parameters within the Microsoft Azure Digital Twin Explorer. The Twin Graph panel allows you to explore the twins and relationships in your instance. You can create a new twin or node in the Models panel. In this example, we create a new twin from an existing model, the production stock model, and add a relationship between the source twin and the target twin, the existing production resources and operations. You can view the property values of a twin or a relationship by selecting the corresponding node on the Twin Graph panel. The panel will display all the properties associated with the element along with their values. It also includes default values for properties that haven't yet been set. Back to the Solution web application. You can set up the production and distribution flow management policies specific to your supply chain. From here, you can select the stock policy to apply to all stocks. For example, by selecting a make-to-forecast stock policy, you configure a policy aiming at replenishing the stock to have enough quantities available to serve the forecasted demand. Then, you can simply edit the demand plan, transportation duration, and production resource opening times tables to modify the existing corresponding values. To adjust the global parameters of the simulation model itself, you start by selecting the desired simulated time horizon and time granularity from 1 minute to 1 year. The Model Behavior feature offers several configuration options related to the default behavior or actions within the production process, such as the production batch size and the financial cost calculations, the production orders and transport durations, or the stock dispatch policy, retain quantities or dispatch all quantities downstream, for example. From the Scenario Manager, you can quickly access the list of the created scenarios and the hierarchy between them, the corresponding simulation status, and the associated dataset. You can change the layout display or switch from the Scenario Manager to Scenario View with one click. The solution also allows you to compare two different scenarios, such as the actual demand and a fluctuating demand, as an example, thus bridging the gap between production planning and demand forecasting. In the case of a fluctuating demand scenario, you can see here the impact on various KPIs, such as the decrease in profit and service level. Moreover, the bottleneck identification dashboard enables the immediate identification of limiting bottlenecks and missed demand by production time step and by product. The bottleneck summary panel displays where the most impacted bottlenecks are located. In a world of continuous disruption, one of the top questions you need to answer as a supply chain manager is, what is the overall resilience of my supply chain in the face of uncertainty? To answer this question, the two previous analyses won't be enough, as they are considering only one random possibility, linked to this demand uncertainty, among many others, and this is not very representative of how things would happen in the real world. Cosmo AI simulation provides a look at all the possible futures of a complex supply chain, letting you test the robustness of your organization and find the weaknesses before they impact your business. Here, the Uncertainty Analysis Scenario Comparison Dashboard compares the uncertainty analysis results on the service levels and profit based on the two previous scenarios. During the uncertainty analysis, a huge number of simulation results data is generated. For this model, the combined uncertainty translates into the automatic launch of 1,000 simulation bundles per scenario. To calculate the overall impact of the uncertainty on the supply chain, the model considers the relative contribution of each source of uncertainty, including all sources of uncertainty. For example, production capacity uncertainty, demand, or transport lead time uncertainty. To better illustrate this, we will use the uncertainty analysis to address multiple cross-functional objectives that can be summed up as finding the perfect balance between profit, service levels, and risk. Now we'll carry out an uncertainty analysis on the safety stock by assessing the combined influence of all the identified uncertainties on the supply chain. Currently, your service level is close to 100%. This is because there are some excess inventories. Based on this information, the question you're trying to answer is, how can you reduce the excess inventory and increase the profit without compromising the service levels too much? To do so, you undertake an uncertainty analysis to quantify the uncertainty incurred by various inventory reduction variations. That means that you'll perform a one-at-a-time variation scenario where you'll vary the safety stock level manually. You start by running the first scenario, where you aim to reduce the safety stock level by 10%. On this chart, you can visualize the range of possible outcomes based on the uncertainty of this first inventory reduction through the lower, medium, and upper values, min, max, mean, of your two KPIs, service levels and profit. Cosmo AI simulation uses a 95% confidence interval, which means a 95% degree of confidence in the simulation results. Here, the 95% confidence intervals range between 98.668% and 99.833% for the service level, and 12.9 million and 14.3 million for the profit. The results of this first inventory reduction show that the safety stock level could be decreased while increasing the profit. By reducing the inventory level, the inventory costs drop as well. So you run a second scenario where the safety stock levels are reduced by an additional 10%. The results show that the profit increase could be even higher with a slight service level decrease. After running two more similar scenarios where you decrease the stock level by ranges of 10%, you notice that the probability for the service level to be drastically reduced and that the profit starts decreasing is too high. The dispersion, which is the statistical measure of these relative results, is higher, which means a riskier scenario. Analyzing the dispersion for these various scenarios helps you understand the level of risk and provides you with a useful risk profile for each of them. As you can see here, for this last scenario, the impact on the service level could be too important, and the inventory cost reduction doesn't compensate for the loss of sales anymore. Another way to find the scenario that reconciles the best service levels, profit, and risk is to compare the overall resilience score of your supply chain for each of these scenarios. The Resilience Score dashboard compares the resilience scores of two selected scenarios. It is a summarized way to quantify supply chain resilience with a single indicator for the two KPIs, profit and service levels. If we look at the last two scenarios, you can see that the resilience score translates the previous uncertainty analysis results. The supply chain resilience score for the third scenario is way higher when compared to the resilience score of our last scenario, which was the riskiest. The second type of disruption that AI simulation technology helps to address is related to unpredictable events. The best way to address this type of disruption is by using the sensitivity analysis. The sensitivity analysis helps answer the following question: where are the vulnerabilities of my supply chain located in the case of unpredictable events? Let's take as an example a transport crisis which translates into a 50% lead time increase. For this type of disruption, the sensitivity analysis will quickly display the most impacted transport routes and suppliers within your supply chain by KPI. These results are also displayed and highlighted in red on the flow map. For example, you can see here that the Mexico to Brazil transport route is a sensitive one, contributing to your supply chain vulnerability. The next logical step you want to take after identifying the top vulnerabilities within your supply chain network design is the mitigation action plan. Let's say your mitigation action plan consists of replacing your supplier from Mexico with a local one. Within a few clicks, you can analyze this new supply chain configuration result. As you can see on the sensitivity analysis top values dashboard, the transport route from Mexico to Brazil is no longer listed as a highly sensitive route, as you manage to significantly reduce the volume of products and goods transiting via this route. This, of course, will have a positive impact both on service levels and profit. And if you look at the flow map, the Mexico to Brazil route is no longer displayed in red. This is how the Cosmo AI simulation twin platform helps businesses build future-proof supply chains that are resilient in the face of disruption or unexpected events. This technology can help you foster true digital transformation in your organization.